All right, this is a little video about the gas laws that we're going to learn. And when we study gas laws, we think of three basic variables to begin with for these three simple ones. And the variables that we talk about with these gas laws are P for pressure, T for temperature, and V for volume. And some units that you'd see here, the pressure, we would see atmospheres, we might see millimeters of mercury, we might see kilopascals, or those are the three basic ones that we'd see. There are a few more that we'll learn in class, but those are a few pretty usual pressure units. Temperature, we see degrees Celsius, but we always convert to Kelvin. And we do that by basically adding to our Celsius temperature 273, and that gives us our measurement in Kelvin. That's important that all of the temperatures in these equations are in Kelvin. And then V stands for volume, and mostly we see this in milliliters or liters, okay? So the first thing to do is think about how these variables all can affect each other, and we're just going to take two variables at one time and see how they would interact. The first law that you'll know is called Boyles' law. And Boyles' law is the relationship between pressure and volume, and it's an indirect relationship. So that means that as one value goes up, the other value goes down. If you have a pressure that is decreasing, it means the volume of a gas will increase. All right, and there's a mathematical equation that we use here, P1 V1 equals P2 V2. These ones are the initial values. That's what the ones are telling you, and then the twos are final values. And in all of these equations that we're going to learn, the pressures, the volumes, and temperatures are changing. So they're changing from an initial condition to a final condition. And you have four variables here, and you'll have to solve for just one of them, meaning that you'll have the other three numbers, and then you just algebraically solve for the fourth. Okay, so Boyles' law is the indirect relationship between pressure and volume. Next one you'd know is Charle's law. So this relates the volume variable to the temperature variable, and this is a direct relationship. That just means that as the temperature of a gas goes up, the volume should go up, and that's probably something that you know already. But also as temperature of a gas goes down, the volume will contract. And this assumes that the gas is unconfined. And that just means that it's not stuck in some container that would keep it from expanding. So you can't expand a volume if it's in a closed up container. So this assumes that the gas is just able to expand due to temperature increase. All right, the mathematical equation for this, V1 T2 equals V2 T1. Again, you're going to be given, or you're going to have the ability to have three of these four variables as numbers, and then you'll just isolate the variable you're trying to solve for and solve. With temperatures, remember that if they're given to you in Celsius, we have to make those into Kelvin. Okay, that's true for this one too. Okay, temperatures in Kelvin. You don't have to have your volume in any specific unit, but the temperature does have to be. All right, and then the last law in this little series is called Gay-Lussac's law. And this is the relationship between pressure and temperature, and that's also a direct relationship. So as pressure goes up, the temperature goes up, and vice versa. And Gay-Lussac's law, this is where the gas is confined. And that just means that it's in some sort of a container that doesn't allow the volume to increase. And so instead of the volume of a hot gas increasing, the particles will push against the container that they're in, and that creates the increased pressure. And here's the equation for that: P1 T2 P2 T1. And again, just make sure that your temperatures are in Kelvin, and you can isolate whatever variable you're solving for and solve for it. So those are the three basic introductory gas laws that you are going to need to know. Alrighty.